Welcome back. Let's have one more box exercise. And now I'm gonna change the initial conditions a little bit. We still have the same f2 and f3 vectors, the same magnitudes and the same directions, but now I'm gonna say that the magnitude of f1 equals 500 newtons, and theta, let it be 20 degrees. So my question to you is, what's the magnitude of the resultant force when you add up f1, f2, and f3? And then the second question is, what's the direction of fr from the positive x-axis? Before you start solving it, I want to mention one more thing about vectors. We can describe them using unit vectors. For example, f2 vector equals 346i plus 200j, and then f3 vector equals minus 480i plus 360j, but you can also represent them like this. f2 vector equals, and then you have this column here. Here you have 346, that's the I component, and then here you have 200, that's the j component. And then f3 vector equals minus 480 for the I component and 360 for the j component. And so f2 vector plus f3 vector, that's this column, plus this column, so you will have 346 minus 480, and then 200 plus 360. And again, that gives you minus 134 and 560 newtons. This here is the I component, this here is the j component. So this is just another way to represent them. You can try using this notation in the second box exercise. And if you're really tight in space, then you can even represent vectors like this. f2 equals, and then you have a row vector, and transposed. And then f3 equals, again you have a row vector, and transposed. When you transpose row vectors, then you get column vectors. So good luck with the problem. Try solving it yourself first, and then I'll see you in the next video. Thank you very much. Welcome back. So let's now solve this second box exercise. You already know what f2 plus f3 is. That's this one here. But I need f1 plus f2 plus f3. I know that the magnitude of f1 is 500 newtons, and I know that theta equals 20 degrees. So how about I define another angle here? I'll call it alpha. That's from the positive x-axis. I know that alpha equals 90 degrees minus theta. That's 90 minus 20. It gives me 70 degrees. And now I can decompose my f1 vector. Since I know my alpha, which is the direction of f1, and I know its magnitude, I can write 500 times cosine 70 degrees, that would be its x component, and 500 times sine 70 degrees, that would be its y component. So that's f1. And I already know what f2 plus f3 is. It's this one here. So I'm just going to put here plus, and then this sum. And if I add everything up, then I will have 37.4 and 1029.8 newtons. That's my FR. And now to get its magnitude, that's very easy. You use the Pythagoras theorem, 37.4 squared plus 1029.8 squared, and then I square root it like this. That will give you, more or less, 1030 newtons. You can see that both of its components are positive, which means that this FR vector lies in the first quadrant. And then its direction from the positive x-axis is the following. Inverse tangent, and then 1029.8 over 37.4. So the y component divided by the x component. That gives me 87.9 degrees. And so if this is this ring here that I have here, then this would be my FR vector. this is its magnitude, and then this is its direction. Phi equals 87.9 degrees counterclockwise. As you can see, it's a lot easier to add vectors when you first decompose them into its x and y components. Thank you very much. Welcome back. I have one more problem here for you. You have a metallic plate here, and then you have metallic bars attached to it, and so you have one force in this direction. Let's call it F1, which is 900 newtons. Then you have another force, F2, that's 750 newtons. And then you have another force here, F3 equals 650 newtons. The angle here is 45 degrees, and here I represent the direction like this. You can see that forces F1 and F2, they pull on these metallic bars, but the force F3 pushes on this metallic bar. However, their lines of action, they all meet here, so I'm going to call this point O, it's the origin, and I'm also going to place my coordinate frame here, XY. And now the question is, what's the magnitude of the resultant force, and what is its direction from the positive x-axis? So try solving this exercise by yourself, and then I'll see you in the next video. Thank you very much. Welcome back. So let's solve this plate exercise now. In order to find the resultant force, it's best to represent all your forces in the Cartesian format. So F1 equals, that's easy, that's 900 in the x direction and 0 newtons in the y direction. Then F2 vector equals 750 times cosine 45 degrees in the x direction, and then 750 times sine 45 degrees in the y direction. And then F3 equals positive 650 times 405 in the x direction, and then minus 650 times 3 over 5 in the y direction. You can see that the x component for this vector is positive and the y component is negative. And now all you have to do is to add up these three vectors. If you do that, then you will have 1950 newtons in the x direction, 140.3 newtons in the y direction, and that's of course in newtons. Then the magnitude of Fr equals 1950 squared plus 140.3 squared, and that's square root, and you will get 1955 newtons as your magnitude. Again, since both components are positive, that means that you're in the first quadrant, and the angle from the positive x-axis is inverse tangent, and then you take the y component and you divide it by the x component, and you will get 4.12 degrees. And so your Fr vector, it will be something like this, and here you will have your phi. And that's how you solve this problem. Thank you very much.